Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. To Selazmi. So today we would like to present about the topic 5.0 network troubleshooting. So we move to next. I'm back. Okay. Okay. So we present about our teammates, our group members. It's me, Kwan Nabil, Muhammad Amirul, and Aiman Muhammad Khan.
So for the step and procedure, first one is discover the attached devices. Second is test the connectivity among devices. Third is analyze the default gateway configuration. Fourth is troubleshoot and reconfigure. And the last one is create device documentation table. So this is the topology. So moving on to the first mistake. So the first mistake is by go to PC1 and change the default gateway. As we can see here from the default gateway 192.168.10.254, we change it to 192.168.10.1. Second mistake, go to S2 and make the interface as no shutdown to make the interface up. So for the configuration, we must enter the interface G0/1, and we enter the command no shutdown. The third mistake is go to router 3 and add the IP for G0/0.80. So for the IP address, we must enter the IP address is 192.168.80.1, and the subnet mask is 255.255.255.0. So the fourth mistake is go to R2 and do the config for OSPF. So as we can see, we enter the router 2, we enter router OSPF 1, and also enter the router sub, the configure sub. So, and then we enter the router ID 2.2.2.2 and set the network as 192.168.30.0, and the subnet mask is 0.0.0.255 area 0. Then network 192.168.40.0. Subnet mask is 0.0.0.255 area 0. The third one is 192.168.50.0. And the subnet mask is 0.0.0.255 area 0. The fourth one is network 192.168.60.0. And the subnet mask is 0.0.0.255 area 0. Lastly is the network 10.10.10.0, and the subnet mask is 0.0.0.3 area 0.
Okay, so we move to mistake number 5 or fifth mistake. So the mistake is we need to change the cable on LP4. This one is LP4, so you can see. So change the cable on LP4 from FA0/24 to FA0/11 following the VLAN as 110 VLAN. Okay. Okay. So for the sixth mistake or mistake number 6 is change the cable for PC5 to FA0/9 S VLAN 90, PC3 to FA, this is the picture. So FA0/6 S VLAN 60, PC2 to FA0/5 S VLAN 50, and LP3 to FA0/4 S VLAN 40, LP2 to FA0/3 S VLAN 30, and LP1 to FA0 S VLAN 20. So okay, this is the number seventh mistake. Mistake number 7. So enable CDP run on R1, R3, and R4. S4, sorry. So discover the attached device. Use discovery tools, example like show CDP neighbors or manual tracing to identify all devices in the network. Record each device IP address, MAC address, name, model, and LS. Note that logical interface like net sub interface SVIs and may not appear in discovery results. Highlight any missing or outdated information. So you need to put command show CDP neighbors like the question given. So show IP interface brief. As we can see, this is our IP address uh, and CDP neighbors detail. Okay. Okay. So we put command show CDP neighbors. Okay, as you can see, KR1 show CDP neighbors details, uh, device ID R1, entry address, IP address, and so on. So this is the command show IP interface brief. Okay. So after that, we need to put command show CDP neighbors. That's as you can see, and GI gigabit 0/1 show CDP neighbors detail and show IP interface brief. So this is the output lah. So for R4, I show CDP neighbors. As you can see, serial 0/1/1. Uh, show CDP neighbors details. So the output is device ID R1 and so on. So the show IP interface brief. So CDP neighbor details. ID R1 address is okay. So next we move to S1 show CDP neighbors. So device ID, this is the output, and show IP interface brief. Sorry. Oh, for S2, show CDP neighbors. This is the output devices, devices ID, and show IP interface brief. So FE and so on, and assign. Okay. So this one is command to show CDP neighbors details. Device ID R2 and the address. So this one is show CDP neighbors, device ID, and this is the output R2 R2 gigabit 0/2, and the last one is show IP interface brief. So the last one is S4, show CDP neighbors details. So the device is device ID R3. Show CDP neighbors. So this is the output is R3 gigabit 0/1, and show IP interface brief. So the first so on is unassigned. So, okay, last but not least, this is the multi-layer switch. So the command is show CDP neighbors details. Device ID is R4. Show CDP neighbors. This is the output R4 gigabit 0/1, and hold time 133 an example. Then the last one is show IP interface brief and assign. That's from me. Thank you.
Okay, so now we'll move on to the second question, that is test the connectivity among devices. So we have test communication using ping or traceroute between all devices. Identify devices that cannot communicate properly. Record connectivity result and highlight any failed links. So from here we can see from LP2, that is laptop 2 can ping to laptop 3. And then for PC2 can be ping to PC3. And then from PC4 can ping to SV3, that is server 3. And from PC1 to LP1 also can be ping. Then ping from PC5 to S4 also can be ping, and ping from PC5 to LP4 also can be ping. And then this is from other network connecting to another end devices. So ping from PC2 or PC3 to LP2 and LP3, as you can see over here. From PC2 or PC3, I can ping to LP2 and LP3. And then from PC2 and PC3 also, I can ping to LP1 and PC1. And then from PC2 and PC3 also, I can ping to PC4 and SV3, that is server 3. And then from PC2 to PC3, I can ping to PC5, LP4, and also SV4. So next we'll move on to question 3. Analyze the default gateway configuration, access router switch and review gateway interface configuration, check IP address, VLAN subinterface, setup and port status, highlight any missing or incorrect configuration. So for R1, as you can see, we are going to put show VLAN brief. And in the show VLAN brief, we can see the VLAN that has been set up over here. And then for show interface trunk, you can see over here for gigabit Ethernet 0/10, 0/.20, and also 0/0.30. So you can see over here the IP is already assigned. And also for serial 0/1/0 and also for 0/1/1. And then we'll be moving on to the next one. This is for R2. In the R2, we can also show VLAN brief. The VLAN has been set. And also show IP interface brief, as you can see over here. We have gigabit 0/0/0/0.30 and also .40, .50, and .60. The IP has been assigned. And then we have the serial for 0/1/0. It's also been assigned. And this on my right hand side is show run. So we can see the IP and the interface that has been assigned. As you can see over here. Moving on to the next one. This for R3. Same goes to R3 also. Show IP interface brief. As you can see over here. The IP is assigned for 0/0.70, for 0/0.80. The IP has been assigned. And then for 0/1 also. And then the VLAN. And also for show run, you can see the IP over here. And also we can see the OSPF has been created. This for R4, same goes to R4 also. Show IP interface brief. Over here we can see for R4 we have 0/00.90, 0/0/0.100, and also 0/0/0.110. The IP has been assigned. And also we have show VLAN brief. And the next one we have show run. You can see over here has been set everything. And then this is for S1, show IP interface brief. And also show VLAN brief. And also for show run. Next for S2, we have over here also show IP interface brief. As you can see over here for VLAN 30, 14, 80 IP has been assigned. Same goes to show VLAN brief down here, as you can see. And then we have show run over here. We can see every details that we have been done in the configuration. This for S3, same goes to S3 also, IP interface brief. You can see VLAN 50 and 60 has been assigned. And then we can go show VLAN brief. As you can see over here, the VLAN has been set over here 50 and 60 based on each of the ports. And also we have show run over here on the right hand side. And then moving on to S4, same goes to S4 also, show IP interface brief. You can see over here, VLAN 70 and 80 has been assigned. And then we have VLAN 70 and 80 according to their port. And on the right hand side, we have over here goes to show run. And then next we will go to multi-layer switch. We will go to show IP interface brief. In the multi-layer switch, we have VLAN 90, VLAN 100, and VLAN 110. The IP has been assigned. And then VLAN 90, we have the ports. VLAN 100, we have the ports. And also VLAN 110, we have also the ports connected. And on the right hand side over here, we can see the show run. And then now we'll move on to the fourth question, that is troubleshoot and reconfig, identify and fix all configuration error found in previous steps, verify all devices can ping each other successfully, and update configuration and confirm network scalability. So as you can see over here from PC4, we can ping to LP2 and LP3. So we have to find any solution to grade it. So first, what we'll do is we will create the route for each of the connection that we have to connect to PC4 to LP3 and LP2. So we're doing router OSPF. As you can see over here, we have created the OSPF route for each of this one. And then for router OSPF 3, and also for router OSPF ID 2.2.2.2. So the solution is by creating the way for it to communicate by creating the default gateway and making OSPF. And then next we'll set up the IP on the S4N routers. So once we have set up, and we'll try to ping the way to see whether it can communicate to PC4 can be communicate to LP2 and LP3. So we'll try to ping on the switch and also on the router. So as you can see over here, when we ping to the default gateway, it can be ping. And then finally, when we ping to the default gateway, it gets so that is the solution that we found that we can fix. And then the last step is create device documentation. So as you can see over here, this is the documentation for the table, IP table. We have device name, device type, the VLAN, the interfaces, the IP address, subnet mask, connected device, and also the description for every of the interfaces. We have R1, R2, R3, R4, S1, S2, S3, S4. We have MLS, that is multi-layer switch. We have PC1, LP1, LP2, LP3, PC2, PC3, server 3, PC4, PC5, server 4, and LP4. So LP stands for laptop. So that's all from us. Thank you, sir.
Thank you, sir.
Thank you, sir.